Imagine pouring a massive concrete foundation. You're banking entirely on a predictable, invisible chemical reaction to hold up a multi-story structure for decades. But what happens when that predictability just completely vanishes? Welcome back to All About Technical Facts. Today, we are diving into a crucial explainer on concrete strength degradation. Specifically, we're unpacking a massive issue in civil engineering, the M20 mystery and those notorious summer cracks.
Okay, let's dive right into this central mystery. Why on earth does concrete, carefully designed as a robust M20, suddenly degrade to a weak M13? So for a bit of context here, M20 is a super reliable, globally used mix. The M stands for the mix, and the 20 is its intended compressive strength. It is engineered to be incredibly tough. But site tests keep revealing a really disturbing reality. This precise, calculated mix is frequently curing at a mere M13 strength. I mean, that isn't just some minor rounding error, right? It's literally like ordering high-grade structural steel and getting flimsy aluminum delivered to your site. It is a massive downgrade that turns a completely safe load-bearing element into a severe structural liability.
There is this terrifying disconnect between the intended M20, the one drafted so meticulously on the blueprints, and the actual compromised M13 outcome you get out in the field. When the physical reality falls this dangerously short of the theoretical design, all those safety factors built into the engineering plans, they are instantly eaten up. Poof, gone. You simply cannot just cross your fingers and hope the building stands. Understanding exactly why the identical proportions of materials fail to reach their target strength is step one in preventing a catastrophic failure down the line. We really have to figure out what is intercepting that strength between the mixing truck and the final cured slab. To solve this, we move to our next section, summer concreting challenges. Let's look at what the harsh elements actually do to our mix. Now, what's really interesting about this slide is the most immediate symptom of this environmental challenge. It usually pops up before you even run a single compression test. You get these nasty shrinkage cracks spreading all across the slab. Cracks in a slab after concreting in the summer? Yeah, we've all seen it. You finish the pour, the blazing summer sun beats down, and the moisture just evaporates way, way too rapidly. Here's the absolute crucial part. Concrete needs water not just to become a workable mix, but to chemically cure. It's an exothermic chemical reaction called hydration. Think of it like baking a cake, right? If you leave the oven door wide open and let all that essential moisture escape too quickly, the internal structure just collapses. When that hydration process is stunted by rapid evaporation, the internal matrix of the concrete simply fails to bond properly. So these visible surface cracks, they are the glaring physical manifestation of your M20 strength literally disappearing right into thin air. But hey, we aren't totally helpless against the heat. The industry has developed exactly 7 instant fixes to remedy and prevent these summer slab cracks. Knowing these 7 fixes is quite literally the difference between a successful pour and a completely compromised failure. And listen, these aren't just polite suggestions. They are proven countermeasures. We're talking about things like shifting your pour to the cooler nighttime hours, actively chilling your mixed water with ice, applying instant chemical curing compounds to seal the surface, or even erecting sunshades to physically block the sun. All these methods exist to do one thing: lock that moisture in. If you are pouring in the dead of summer, taking control of your job site and mastering these 7 fixes is absolutely non-negotiable. So let's bring this all together. The crucial point is we started with a pretty terrifying reality. Your highly reliable M20 expected grade can unexpectedly and dangerously degrade all the way down to an M13. We found the primary culprit, which is that intense summer heat severely impacting slab integrity by causing rapid moisture loss. And most importantly, we identified the solution. There are 7 known instant fixes out there to combat summer cracking and protect that vital curing process. Understanding this delicate relationship between the chemical mix, the weather, and our own human interventions, well, that's what bridges the gap between flawless paper designs and the really harsh realities of the field. Which brings us to a really critical question for you. Are your current practices actually protecting your concrete's true grade? It's one thing to know that the summer sun is your slab's absolute worst enemy. It is an entirely different thing to objectively look at your own job site and actively implement those 7 crucial fixes. Every single time a truck rolls in during blazing heat, that concrete is at risk. So are you leaving your structural integrity up to chance and the weather, or are you taking deliberate control of that hydration process? Keep investigating, review those summer fixes, and please never take your concrete's true grade for granted. Thank you so much for joining me on this explainer here at All About Technical Facts. If you found this practical and valuable, make sure to like, share, and subscribe so we can keep bringing you more engineering deep dives. See you next time.